Okay, we're going to introduce some threads to this code. So before we like jump into putting it right in the code, let's actually just focus on the thread part first, so that we make sure that we get the threads correct before we start making it work with our hash table implementation. So to use threads, we're gonna need to use pthreads. So I already have included pthread up here. So so we need to create a pthread function. We'll call it gen content. So here's our pthread function. I usually use void v. That's what I usually use because we're going to end up casting it to something more interesting. And we'll define a structure for the arguments that we want to pass. So the question is, what do we want these threads to do? Well, these threads are going to be inserting into the hash table. So we want to generate some node strings. So let's actually let's have a start value. So this is or should we have a start? No, let's have a count. The number of nodes it's supposed to generate, and let's have let's have a start value. So the index that we're supposed to be starting at, so we can generate mostly the same strings as we did before. And let's see, I think this is it, right? We have the start and the number to generate. So when we do our gen content, we're going to pass this in. We're going to get this gen arg structure, call it args, and this is going to be a pointer. And we're going to set that to v. So just to make sure that everything went okay, we will say, let's print those two values. So args start and args count. Okay, and then here, let's say we want to do 1,000. We want each thread to do 1,000, so we'll need 10 threads. So we need, we're going to loop and create 10 threads, and then we're going to have a structure, gen arg structure. Okay, and this is going to be, you can actually do this where we say start is I times 1,000, and then we're going to do a count. We're going to do 1,000 for each thread, and so we do pthread create. Now we need to have the thread handle. So we want to keep track of those in an array. So we need to go back and create the array. Get the attributes. We're just going to use the default ones. We're going to call gen content, and then we are going to pass args, this arg structure, as the parameter. So let's declare the thread handle array. So pthread t, this is our thread handle, and there's going to be 10 of them. Okay. Oh, and then this, we need to pass a pointer to, because we're going to pthread create will set that. So I think that's right. Oh, and then after we do the create, we want to do join, because we want to make sure they've finished. So we're going to loop through the list again and do join. DHI. We don't care about the return code, so let's put a null there. So let's run this, see what happens. Oh, doesn't know about pthread create and pthread join. We need to tell our build file to use pthread. So we need to add target link libraries structs. Okay, CMake is horrible. I'm not a big fan. But this is what you need to do. So you need to say, okay, this structs executable that we're building, I want it to include the pthreads library. So you say pthread. This should do it. Let's see if it works. Boom, it worked. Yay! Okay, but you'll notice they're all the threads are getting the same value. Why are they getting the same value? Well, if you look back here, this genargs, this is a local variable, and it's a local variable inside this block. So each time we run this for loop, the local variable is going to go away and get recreated. But since the local variables are created on the stack, then it will actually get created in the same place. So if we actually put a print statement here, let's put a print statement here. Print the address of that v. So if you look, it's sending the same address. So basically, by the time the thread runs, they're all looking at the same memory for their arguments, and so whatever the last thread got, that's what they will see. So we don't want this, right? Now there's a couple ways we can address it. We could do another array, and so that we have a unique element in the array. We need, or another common way to do it is to use malloc and just to allocate something on the heap. And let's use malloc to do that. So we're going to say malloc size of args. We need to make sure that we do star args here because we don't want the size of a pointer to the structure. We want the size of the structure, so we need to dereference that pointer to get the size. So now we say args equals, star args equals. Okay, and we try. Now you notice if we try and run this, I think we have a compile error. Yeah, it doesn't like this. This is an initializer expression, but we're doing an assignment here. So we actually just, if we put a cast, this should fix it. Let's see if that works. Boom. All right. So, oh, yeah. Well, so we get garbage. We get garbage. What's going on? Well, it turns out args now is a pointer to genargs, so we don't need to dereference it. So we were actually passing a pointer to a pointer. We actually want to just pass args there. So let's run that. And we see that we got something working. Cool. Okay, now, but we do have a malloc, and there's no free. That's a memory leak. So we know we need to put a free somewhere. The obvious place to put the free would be here, which is wrong. But let's see what happens when we put it there. Yeah. So it didn't crash, but we do see we got some funky behavior here. Things aren't quite looking correct. And the reason is we're doing a use after free. We've done a free here, but the thread might not have started. So after we do this free, the thread might run. This gen content function will run, and it will use that pointer that we freed and find something there. So this is kind of one of the bad cases because it didn't crash, but we really want the lifetime of this, much like we saw with the list. We want the lifetime to last as long as we need it. So the free should really go here because we want those arguments to persist until the gen content is done using it. So let's try running this. Okay, and this looks good. Yeah, they're not in order because, threads get scheduled and arbitrary orders, but yeah, this looks great.